All right, and we are live. So, hello everyone, and welcome to another Kopernik Reactions live stream. As you can see, I'm not at Kopernik right now. I'm just streaming right out of my home. So you might see a cat venture across the screen every once in a while. But our Kopernik Reaction streams are designed to be a watch party for major events in space exploration. So, of course, if you don't want to hear me talking and interacting with the chat throughout the show, this isn't the place for that. That you just go direct to the NASA live stream, which you can just find on YouTube by searching for OSIRIS-REx. We are going to be paying close attention to the NASA footage, and it's a reaction, so I'll be reacting, you'll be reacting, and we can chat about it in the stream. It's a very informal way to just enjoy this and create a platform where we can discuss it with our community. So in the live stream today, in the big window, we're watching the NASA live feed for this event. Of course, you have me. I am Kopernik's live stream astronomer. And above me, we have OSIRIS-REx on Eyes on the Solar System, which is something you can go to right now. If you do a search in Google and just put NASA Eyes on the Solar System, you can access what you're seeing on this display there. And it's a 3D interactive model of that mission. Right now I have it tracked to the sample return capsule for OSIRIS-REx. But you could even go and find the main OSIRIS-REx spacecraft that is currently traveling to asteroid Apophis. So these two craft have separated at this point. One's going to continue on in space, like I said, going to explore asteroid Apophis, and the other is going to return to Earth today. And that's what we're here for, to watch. So I see some people in the chat now, so good morning, everyone. I'll be paying close attention to the chat throughout the stream. So if you have any comments or questions about the event, feel free to post those there. I'm going to bring up my interactive window for Eyes on the Solar System too, so that we can adjust it accordingly. I'll show you, again, that's the window just above me. And I can click and drag and see this 3D view. You can see the Earth behind the capsule there. You can zoom out. And as I said, this isn't the only spacecraft you can view in NASA Eyes on the Solar System. There's a whole host of objects and missions that you can explore. You can also just explore the solar system in general. And it's all through a web browser. You don't even need to download anything. So it's a great resource for you. We'll mostly focus. See, if you look in the background there, you see all the other missions. There's Parker Solar Probe. And around Earth, you have all the Earth satellites, Landsat, Aqua. And you can even travel through time. You can speed things up. Just out of curiosity, we'll give you a preview of the landing. I don't think it's going to show it. Well, maybe let's see what they have animated for this one. Sometimes they animate the full thing. We're watching an animation in the big window through the NASA live stream as well. You're seeing that process play out for the capsule. There goes the touchdown that we're hoping to see today. Let's go even a bit faster on this footage. And the landing is scheduled to happen at around 10:55 today, so not even an hour from now. All right. So on the eyes on the solar system, we're seeing it at around 10:30. And it's going to land in Utah. In a nice open desert area. Let's see what they've modeled here. Let's see if they take you through the whole process or not. Oh, maybe. We're starting to see some atmosphere there. Hmm. Doesn't. Oh, no. So now it tells me it cannot exceed mission end. So that's the limit. That's as far as you can go. Sometimes, I remember, I think for Perseverance, they modeled out the entire process as it landed on Mars. But here, it's just a capsule landing. Maybe not as terribly. They were not worried about animating that process. But let's go back to live so we can see where it is currently with respect to Earth. All right, we'll leave that window up. Let me check the chat. And again, this is NASA's Eyes on the Solar System. So, oh, good morning, Janet. And Shaitan asks, can you please provide full quality footage of the Perseids? Yes, I did intend to put that video together, but that kind of got away from me. I will see if I can still release that. My one problem that I had, but it doesn't like completely uh, destroy the idea of posting that on our channel, is that I only captured on camera about 30 minutes of footage because I forgot to turn off my limiter. So it captured like the half hour of the meteor shower and then it stopped. But I do have the non-streamed data that was coming into the computer, the raw data that was being fed in there. So it might not be the best quality compared to what I was recording on the camera, but I think we can maybe still get something out of it. So yeah, I will see what we can do there to retrieve that. Good morning, Regina, and good morning, Joe. Yes, Big Dog says 40 minutes. Yeah, we're counting down the moments. In fact, I want to make sure we tune into the NASA stream here and there because that's what we're really here for today. So let me bump up the volume on that and let's see where they're at. It looks like they're at the landing site in Utah.
They've been briefed on the actual items that we've dropped out here in their range safety brief. One of the hazards that we're going to be dealing with, though, is the helicopters that you see behind us, and they've been through practices getting on and off the helicopters and working in and around them. But I think the biggest hazard that we're going to have is slipping. We had some recent rain, so that I think is going to be our biggest hazard, but it could be fun too. So.
Well, wonderful. I know that you have your last preparations for the day, so I'm going to let you go, and thank you very much for joining us.
Thank you, Sophia.
Thanks, Sophia. Stu's got a big day today.
Oh, my goodness.
A lot to do. All right, Jim, we know we have space fans from all walks of life all over the world. One super fan in particular is a well-known astrophysicist with an atypical side hustle. But I'm guessing you know him probably more from his side thing than his science thing.
Well, that's right. He's literally space royalty and rock royalty. Perfect for a mission to bring back rocks.
Just a true rock star. Let's let him speak for himself.
Hello NASA folks, space fans, asteroid aficionados. This is Brian May of Queen, as you know probably, but also immensely proud to be a team member of OSIRIS-REx. I can't be with
Oh,
you
I don't think
today.
I knew
I wish
that.
I could. I'm rehearsing for a Queen tour, but my heart's there with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission, especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking of rock stars, joining us is NASA's Lori Glaze, Planetary Science Mission Director. Welcome, Lori.
Hey, good morning. Great to have you here, Lori.
Great to have
you,
you. And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here. What an exciting moment.
Lori.
Thank you.
It is a really exciting day. So
Lots
OSIRIS-REx
Lots of passion coming through the NASA stream there. And it looks like they have asteroid Bennu on the table, a nice 3D model of it. For those that were wondering what is this all about, OSIRIS-REx traveled, well, it launched in 2016, about actually the same month, September 8th of 2016, and it traveled to a rubble pile asteroid, a carbonaceous rubble pile asteroid called Bennu. And that's a near-Earth object. So right now it's about half an Earth-Sun distance away. If you want to know the miles, let me look. I can't remember that one. Right now, distance from Earth is about 51 million miles away. So it's actually pretty close. And in that, to that end, it is an object of higher risk. Like there actually is a chance within the next 150 years or so that it could impact Earth. Now, it's not a terribly large object compared to some of the asteroids we find out there. It's like maybe a third of a mile in diameter. It's still, you're talking about 1,600 feet. And if it made it to the surface, it would certainly have an impact. But it's still, low chance. It's 1 in 1,750 chance of hitting Earth in the next 150 years. So I wouldn't worry about this one too much. And more so, they're interested in its overall structure as a near-Earth object, what it's made up of. Asteroids are some of the oldest unaffected rocks in the solar system. So when you go visit one, it's very early solar system material that you'd be studying. So that informs us about how the solar system itself formed. And all these the Earth was composed of all these little asteroids and planetoids starting to smush together. And as a rubble pile asteroid, that's basically what's going on. It's tiny little pieces of rock, pebbles, dust, all clumping together to form this larger asteroid. So let's see, I think I have, where'd my lithograph go? I wanted to show you this because we had the chance, Kopernik staff and interns had the chance to visit Goddard Space Flight Center. Oh, here it is. Back at the end of August. And we were given this lithograph of the... Oh, it's actually perfect timing. Look at that. You can see the spacecraft pick up the material there in the NASA feed. And this is that lithograph showing that exact thing of the sample arm retrieving somewhere between 400 grams and 1 kilogram of material. And the mission would have been considered a complete success if it only got 60 grams of material. So they got more than they were hoping for. And that's all coming back to Earth today. All right, let's see. Oh, we got some more chat in here. Oh, my dad is in the chat. Hello, Dad. Yes. Yep, I can bump up the audio now. I'll return it.
Of the SRC all morning. They've been there in the room, prepared and ready to go. I'm sure they are absolutely thrilled for this moment. They might even see themselves on the screen there in a second, but they are hype and ready to go. This is the Lockheed Martin team just a little bit north of us in Waterton, Colorado. They are also dialed in. They're the ones who gave that initial command this morning to release the SRC from the main OSIRIS-REx spacecraft. You just heard from Lori that OSIRIS-REx is now on its way to its extended mission. OSIRIS Apex visiting that near-Earth asteroid Apophis. A lot coming up in just a few moments. We're going to hit that key milestone of entry, descent, and landing. 13 minutes of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range. A lot coming up in just a few moments, but for now, back to you, Lauren and Jim.
Thanks, James. Very soon, NASA's Artemis program will be
Some
bringing us
more people tuning in. Good morning, only in a dark night.
Familiar beacon in the sky. Give us 60 seconds, and we'll give you the moon. Artemis 3 will be the first sample return mission of NASA's Artemis program, sampling rocks and regolith from one of 13 candidate regions on the moon, all located near the lunar South Pole. The Apollo lunar landers returned a treasure chest of samples that taught us about the history of the solar system, dating back about 4 billion years ago. Artemis missions will explore areas near the South Pole on the rim of the moon's oldest basin, the enormous South Pole Aitken Basin. Artemis will explore areas nearly 1 billion years older than those explored by Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the moon and Earth, as well as increase our understanding of planetary processes. OSIRIS-REx, the first U.S. mission to collect a sample from an asteroid, will return samples from asteroid Bennu. The rocks and dust collected
There's that same animation I showed you with the lithograph too.
Were forming over 4.5 billion years ago.
Let's hold it right up to the camera, showing you that arm. It shows up okay over the camera.
And that's a look at your
But picking up the sample
Boy, Jim, how can you not get excited about that?
just quickly touches down and scoops it up.
All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
Right, let's see.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Ah, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy that a mission like this has?
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
The moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great. Thanks, Sophia. Wow, I can't wait for Dante to get his moment in the sun.
Goes Dante.
That is amazing. All right, so Jim, the whole OSIRIS-REx spacecraft is not coming back today, right? It's just a part of it.
That's right. This is the whole spacecraft, 40 feet long, the size of a school bus. But this special little thing here, the sample return capsule, is bringing home the goodies. And that's what we've just released, and it will be entering the atmosphere, and you'll be hearing all about it. And the samples were collected at the asteroid back in October of 2020 from this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this this replica
this full scale, I think.
capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies, the sample return canister and the sample cap, the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is, and it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from Bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
the real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the OSIRIS-REx sample return capsule on its return to Earth. This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests today. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12
That's an interesting transition.
or about 27,000 miles per hour.
Like it burst through the asteroid.
Orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International, and universities in Australia and Germany, SciFly is coordinating 3 ground stations and 4 aircraft to collect data on the sample return capsule's trajectory, heat shield performance, and the plasma environment surrounding the capsule as it speeds to the surface, all of which will help NASA understand its performance and help future planetary entry missions succeed.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made to, a day like today a
I got to see if they have that 3D model of Bennu available.
Within NASA and without, so we outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland.
So we're 3D printing that.
Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation.
Wow.
We have a science team led by the University of Arizona. And then we have
recovery operations. Helicopter 1 has departed route to station keep outside the landing ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science, an expert on how our planet works in climate, can you tell us how this asteroid mission, the samples we return, might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice. Being with the team and thinking about, this spacecraft launched 7 years ago. And now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard. And are you going to stick around for the show?
Awesome.
Fantastic. All right. Well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for
Wonderful.
all you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because of its
Recovery operations. Helicopter 2 has departed WIG. The station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent
Whoa.
progress. Fantastic. Woo. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest
That's a good
object to
name
be
for it.
orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Okay, 2 of the helicopters have already just departed, so the team is already in the recovery process, or at least the beginning phases of it.
Less than 20 minutes
Now we
before
are waiting to hear precisely where
landing.
the capsule is going to land before the rest of the teams head on over to that location. Now we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is
how exciting.
51 years since we've had such a pristine and large sample of ancient solar system material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational
And we really are in for a new phase of, I mean, they mentioned this a couple of times in the video, but we're definitely in for a new phase of extra solar system material beyond Earth returning to our planet for study. So we've got the Artemis missions returning to the moon. We have this OSIRIS-REx, and we have the Mars sample return mission as well, with Perseverance collecting those tubes of material at various locations at its site at Jezero Crater. So I think we're about to see some pretty important data come down from all of those samples from different objects in the solar system. It is pretty exciting. I just wanted to let you know I did bring the volume down on the video just for a moment so that I can tell you that there is a 3D model I found through NASA's 3D resources of asteroid Bennu. And if you like 3D printing, if you have a 3D printer at home, that is a resource available to you. I did take a quick glance at it to see what its quality was like, and I might need some touch-ups, but it looks a little bit polygonal in some spots. But other than that, I think it'd be a pretty nice object to print, even if it's just to get the general overall shape of it and give that tactile feel to this object that's millions of miles away. I think all the data that was used to build that 3D model came from OSIRIS-REx. So I think that's pretty powerful to turn it into. Oops, there we go. To turn it into something that you can hold. Paper Moose says the library has a 3D printer. There you go. Could be a fun object to print and then try out. And not just that one too. You have a whole bunch of objects through those NASA 3D resources that you could look for. Spacecraft, other objects in the solar system. They even do some tactile galaxies, or not even just galaxies, just images of the sky. We have one at Kopernik that is Stefan's Quintet from the James Webb Space Telescope, so that you can actually feel in a 3D space how this object is structured. All right, let me turn the volume back on. I see there's some wholesome conversation in the chat going on, and that's fun to see.
James,
thanks.
we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Wow, how comfortable.
Operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple minutes away from this key moment. It's going to be very exciting next
Eyes on the solar system.
Here.
We're getting close.
Hear a couple call-outs come in from
this is live, simulated live up there, by the way.
To get us ready for this key moment. It's a journey of 3.86 billion miles, getting reduced to the scale of mere miles. 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability. Stabilizes our descent and makes sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago, gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing.
Oh, they have an actual OSIRIS-REx. Right? Did you see that red dino?
SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing.
Maybe even a couple of them.
Expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now.
That's cute.
This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky.
Look at that. We're kind of seeing an artificial meteor, you know?
At this point, we've entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 g-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDL milestone, SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute, waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS-REx spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere.
That did look pretty cool. I don't know if I'm seeing much.
Nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite
footage.
a
Oh no, I do see it
as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft.
Oh, that's good though. Nice soft landing. Gentle.
SRC. Streaking in. This is from our high altitude cam.
This is some pretty incredible tracking they're doing. I wasn't expecting this level of footage necessarily.
Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within that just a few years ago was on the other side of the solar system from us sampling an asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see
EDL milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range.
The closed captions do look cool. They're not tracking quite right.
Camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain, the team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range.
It is fascinating to see the
like
level of zoom that they're at to capture this. It makes it look like it's a lot closer than it is, but it's just such a small craft.
The slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within.
Fantastic.
According to my watch, we're about 5 minutes away from
butterfly net needed. That's good copies.
And as we heard a few moments ago,
a big one.
1 and 2 are already staged.
Improve your surface area that way.
Operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great
I like that they're describing as creamsicle colored.
Now from
it does look like that.
As it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour.
That's incredible.
Incredible amount of deceleration there, as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing
EDL milestone. We have touchdown.
Oh.
Repeat, EDL. SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid.
There it is.
Reaction there
Best shot.
just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous
That's what we want to see.
of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins of our solar system and potentially the origins of life. We're not in the clear just yet. A key piece of the mission is about to get underway. This is the recovery operation phase. Once the team has officially confirmed the exact touchdown location, they'll be flying out on 4 separate helicopters and will operate much like a Formula One pit crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep, collecting samples along the way. You see our mission ops team just next door. I once again remind you that the sample canister itself is not actually going to be opened here at Dugway. The next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag sim that just a few years ago collected pieces from the asteroid Bennu.
Okay,
Today,
so
the
they're
goal is to get the sample canister.
Recovery operations. Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that landing ellipse. These helicopters will have a trip out to find that exact touchdown location of the SRC and begin those recovery
let's
operations.
get eyes
Stu
on
Wiley,
it.
our on-scene commander, will be the first person to approach that SRC. He'll do an environmental safety sweep, checking for unexploded ordnances. As he mentioned in his interview earlier with Sophia, he understands this range. He's worked here for a number of years. He will brief the team on any possible dangers that would be presented to them as they begin those recovery operations. And then a team member from Lockheed Martin will begin to take gas and thermal readings once the area is safe of that SRC to determine whether or not it is at safe operational levels for the rest of the team to begin the recovery operations. As I mentioned, this is going to be simultaneous action. The team has prepared. They're all going to be wearing these bright white UV shirts, sample recovery shirts. And you'll see them walking out to that sample in just a few moments here once those helicopters land. A great view once again from our high altitude plane. You can see the parachute there next to our SRC. There is a possibility that there could be unexploded ordnances from that parachute. There is a mortar inside that is to fire to disconnect the parachute from the main SRC to help it come to a final rest. It's a bit challenging to see from this perspective, but there could be some potential roll marks or skid marks as that SRC came to a rest on the rugged desert surface below. As I mentioned, we did have a bit of precipitation here the other day, so that should make for a nice soft surface for that SRC, so it probably had a nice clean landing there. The team will assess as they get out there and check exactly how
there's the parachute.
conditions are for the SRC and the surrounding area. You heard Stu mentioning the team might need to wear some boots. The operations could get a little bit slippery as they begin to recover that sample. And this is a pristine sample from the ancient solar system and could hold the clues to how everything around us came to be, from the formation of the planets to the origins of life here on Earth. Needless to say, this is precious cargo, and the recovery team is fully aware of the gravity of the situation and the importance of what they're about to do today with these recovery operations. You can see it looks like our parachute has come to a stable rest. The winds were pretty low today, so it looks like it is not billowing at all. It is almost perfectly flat, at least from this perspective, on that desert terrain. And throughout...
It's all, the narrator's doing such a good job. I've just been letting that go. I've been engrossed in this just as much as I hope everyone else is. But yeah, it's pretty fascinating to see where they ended up landing this. It makes a lot of sense. Big open desert, but also kind of a neat perspective to see us landing a capsule on Earth in I wouldn't call it an alien um, space on Earth. I mean, we know deserts. I'm sure you visited one, but it's still like it almost has a Mars feel to it where they landed it. And it's just fascinating to see us land a capsule like this on our planet versus sending one out to Mars, to the moon, and so on. It's just a neat perspective I'm picking up on as we watch this footage. Um, and the narrator's doing a fantastic job, really keeping the audience captivated here, and myself. The spacecraft that I just put up on Eyes on the Solar System. Again, this is something that you can do too. In a web browser, you can jump to Eyes on the Solar System and now see the capsule. It won't show you in any great detail anymore. It's landed, but we're watching that live in that simulation. Now you can go and track the OSIRIS-REx spacecraft, and you can see Earth behind it here. It dropped off the SRC, and now it's flying out to on a trajectory to get to asteroid Apophis. So we'll just keep that up there for now, just because it's relevant to the secondary mission that spacecraft will now perform. We'll get back to the NASA feed here in just a moment. I just want to check on the comments and see if I missed anything. Might need to wear boots. All I ever wear is boots. It's a good rule of thumb. May as well. Wonder how hot the capsule is. Yeah, we'll see if they mention anything about that, and how long it might take to cool down before actually recovering it. Joe suggests cooling off in the mud. Yeah, actually the wetter environment that they mentioned before may be beneficial. Oh yeah, Bobby's. I'm sure there's so much excitement from all teams, but especially those that actually get to recover the samples. I mean, I can't even imagine what that feels like, to pull this raw material out. And of course, this is all going to be done cleanly. It's not necessarily like you get to hold it by hand. It's the same thing with moon rocks. It sounded like they were setting up a portable clean room, so that they can actually recover the samples and then ship it off to their destinations of study. That I'm not sure where they'll end up first. Maybe they'll mention that in the video here in the feed. So let's jump back.
100-foot long line beneath one of the helicopters, and they'll actually be flown to the clean room. This was determined to be the best.
Oh, that's a thought paper moves. Maybe it's fired some clay in the mud. That'd be cool.
Nitrogen purge and maintain that pristine nature.
That'd be an artifact itself.
As I mentioned, this is an enormous ellipse, 37 by 9 miles. It's a large expanse to cover by car. It's a very bumpy ride out there as you kind of start to make your approach across this rugged terrain. With the helicopters, it will be approximately a 20-minute flight back with that SRC. They take it at a nice slow pace, effectively parading the SRC around, just giving it its last big moment as it is served its purpose officially at this point of getting that sample canister safely here to Earth. Once we actually land and begin those recovery operations, you'll see a lot of team members out beginning to take samples, both air and also soil samples from around the area. These are places of interest for the sample curation team that will actually open up the sample canister in the coming days down at the Johnson Space Center in Houston, Texas. They have a phenomenal sample curation facility there, and these samples from asteroid Bennu will join a historic collection of other asteroid materials, including samples from the Apollo mission, samples from both the Stardust and Genesis missions, as well as Antarctic meteorites that were collected by our scientists. In the coming days, we'll actually know exactly how much sample we got back from Bennu. The original mission requirement was 60 grams of pristine sample from the asteroid surface. Based on some very clever engineering, the team believes that they have potentially 250 grams, or 6 times that mission requirement, inside. And so we just heard that unofficial touchdown time was at 8:52 a.m. Mountain Time here at the Utah Test and Training Range in Dugway, Utah.
A bit earlier than
If you're just
projected.
joining us, you see that
That's
view right now
interesting.
from one of our high-altitude planes observing our touchdown location. On your screen just above that crosshair is the orange creamsicle-colored parachute that brought us the last part of our journey down to the surface of the Earth. You heard from Jim earlier that main parachute is about 24 feet across. Fairly large parachute that helped us decelerate on our last leg of the journey.
Just because of the play of the terrain there, for a second it almost looked like it was, in the orange parachute, of course, it almost looked like a flame.
So we just heard a confirmation actually
But
that the main parachute
it's just
deployed
the
much higher
parachute.
than it was originally anticipated. It was originally supposed to deploy at about 5,000 feet elevation, but it actually deployed at around 20,000 feet, so much higher up. So that would explain our kind of earlier touchdown time than expected here. Still has touchdown on the Utah Test and Training Range.
FW asks, what is the size of the canister enclosing the samples? They showed a 1-to-1 scale earlier of the SRC. Now, I don't know if you mean like the actual canister inside the capsule itself. That I don't know exactly. But the capsule, the sample return capsule, from what it looked like, is if you took your arms and wrapped it in a bowl shape. That's about the size of the capsule, roughly. Maybe a touch bigger than that, but that's, and then the samples are embedded in there.
And here, relaying any possible info over to our recovery teams as they begin to make their trip out to our SRC. One of the first goals once the team gets out there is to safe and stow the parachute and begin to mark places of interest, as I mentioned, for that curation team to begin sampling. This is all a very well-coordinated machine, very well-oiled machine that operates in tandem. They've rehearsed extensively for this moment. So we just heard from the team in that mission operations room that they have visual of the parachute, that orange parachute that you saw on your screen moments ago. But we do not yet have visual confirmation of the SRC itself. The team is continuing to survey the region, looking for that sample return capsule.
Recovery operations. Kilos 1 and 2 are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Prizer, who you see on your screen there from the mission operations room. He just announced that Helos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments.
Okay.
Helos 1 and 2 will be surveying this region, looking for both that SRC and also eyeing up the region, looking at that parachute that was deployed.
Recovery operations. All of the ground supported vehicles have left rig and are in pursuit of the landing zone.
So some more team members are going to be heading out to that landing zone as well in support of those.
I don't know why that phraseology, it sounds so funny to me. It's like they're chasing this thing down. It's as if it's almost moving. They're in pursuit.
And ready to prepare for recovery operations.
Mildly
Close
amusing.
that on long line. You can see some Once again, some team members pointing at items on the screen here. We'll hopefully get confirmation in the coming minutes of that SRC location. Tim Prizer pointing at the screen now, wondering if he has any more information for us on where that sample return capsule location would be. We do have visual confirmation of that parachute, as I mentioned. Rich Witherspoon radioing out to the team. And now we have a view from our helicopter of the landing location. You can see.
Oh yeah, there it is. Took me a minute to find it.
Capsule dead center in your screen, that kind of dark gray black object right there. And then just to the right of it, below is our parachute. It appears to be resting on the surface. We're getting a zoom in now from our NASA helicopter. And you can see now the SRC. At last, we have a visual of it on the surface of the Utah Test and Training Range. I'm sure that is a pleasant sight for the team to see.
Recovery operations. Helo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protects it the whole way down through that entry, descent, and landing.
Oh, it's so lovely.
Celebrating that moment. I'm sure they're breathing.
Almost doesn't look right.
Here. It's been a wild morning for everyone involved.
Just it sitting on its nose like that, just so perfectly balanced, is fascinating itself. I'm sure it has a little bit of a divot in the terrain there to hold it in place, but it's pretty perfectly balanced. That's amazing. Doesn't look like it's leaning against anything.
So now that we have visual, the teams should be able to begin the recovery operations in just a few moments. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it there, just a little bit off the edge of our SRC. The SRC looks quite charred up from that entry in. That was expected, as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere. You can see a great visual of some of that rugged terrain.
Yeah, it's right next to the road, isn't it? That's nice.
Expands, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid regolith. This mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then actually transporting it back here to Earth for us to open up and analyze.
I'm confused about the edge of the solar system. Like, I mean, maybe that's just how they're describing it for this case, but it seems like this is a near-Earth object. It's not terribly far away, and I mean the fact that there's a chance that it will impact Earth means it will remain fairly close to us. So I don't know. It's just interesting choice of words on that front. It keeps every time they bring it up, I think it's confusing me.
And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Helo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep. As I mentioned, our on-scene commander, Stu Wiley, will be the first person of the team to actually approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range. and then also make sure that that SRC is safe for our operations team to approach and begin recovery.
Waiting so patiently.
You can see where that parachute disconnected from the top of that SRC. That is the back shield that you see right there.
It's saying, "Come open me up."
That little bit of white wiring still coming out of the top. Our SRC perfectly landed there on the Utah Test and Training Range. So what you're about to see happening next is the process of recovery operations. This is a key moment of today's events to actually get that SRC from out in the desert into our portable clean room here at Dugway. It is crucial that we maintain the pristine nature of this sample that we got back from asteroid Bennu. It could hold the clues to how everything around us came to be, from the formation of the planets to origins of life here, so the team understands just how crucial the contents of that SRC is, and they're going to work as efficiently and as safely as possible to get that SRC contained, wrapped up in thermal blanketing, placed in a sample carrying fixture, and then attached with long line to our first helicopter there. It'll then be transported the long journey back here, a much more relaxing flight, I'm sure, for our SRC, to our portable clean room at Dugway. At which point the team members will extract the back shell and remove the heat shield from the SRC. It's served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the asteroid regolith out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, and this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Kilos 3 and 4 have been cleared to land at the recovery site.
And the rest of the team is closely behind, ready to land at the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations.
All right, recovery starting soon. And that's probably where we'll wrap up the stream, is once they get out to it and start, because this is going to be a multi-day effort for them to, to collect it, get into the clean room, process it, and then send it out to its locations of study. So from here on out, it's mostly. I think maybe we'll see it in the clean room today, and we'll see that process play out at some point. But this is science that's going to be happening for at least the next year, if not many years to come. So, and we'll look forward to that. But let's go back here. We should start seeing people walk out soon to start the recovery process.
Begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm. As I mentioned, it heated up to over 5,000 degrees Fahrenheit. So as the cool desert air begins to cool down that SRC, we want to make sure that it is cool enough for our team to actually begin those recovery operations. We'll also be checking the gas levels of that SRC.
Thanks for joining us, Regina.
Outgassing from the batteries.
You have a good day too.
During that reentry. We'll also be making sure that there is no live voltage present. And we see a view now from our high-altitude plane that has visual of those helicopters landed nearby, just at the northern part of your screen. You can see one of them on screen now. The top of your screen there, it is centered up. There is our helicopter, and it appears that we have our on-scene commander potentially walking over. This is, once again, our high-altitude WB-57 shot of our helicopters landed at the LZ, our landing zone. You can see some movement on the screen. It appears some team members might be approaching our SRC at this point to begin those recovery operations, the initial safety sweep. We'll just be observing from this high altitude for the next coming minutes, as the team actually will be setting up a camera on the ground for us to observe the recovery operations close up. And a note from one of the team members about the SRC itself. So They have approximately 40 hours. That is the amount of time it would take for any air to get into the sample. As I mentioned
hi,
before,
Maha
that sample
from
return capsule
LA.
is a complex network
Yeah,
of piping and tubing
happy
inside
to
of
be
it,
streaming this
sort of like a
this out.
labyrinth-like
Our
design,
reactions to it.
and that is intentional
NASA's putting
to
in
make
all
it
the effort
incredibly
today.
difficult for any possible contaminants from the atmosphere to get into our sample canister. It's also sort of like a nesting doll, if you will, where it has multiple layers of protection that keep that sample safe within. All of that protective layering, once we get that sample into the clean room, will be shed, and we'll be able to actually access that sample canister within.
All right,
the main goal, as I said, for today is to get...
Also, before, because I know some are starting to leave for the day, I do want to mention that we are going to have a speaker for OSIRIS-REx come in October. Let me get the date right for you here. In October, and it is October 27th, is when we'll have our Friday night live stream on OSIRIS-REx. And I'll be announcing more details on that soon, but just know that we are going to have a nice presentation on that. And it's going to cover the mission and any up-to-date information at that point about a month into the future, and where this mission is and where those samples are and what they've studied to this point. Even a month out, it's still going to be early days for OSIRIS-REx, but it will be nice to get a lot of details from a subject matter expert. So look forward to that on October 27th. And that goes actually for all of our upcoming programs. We're going to be rolling out our full slate of fall events in the next few days here. So you can look out for that on our website and also on our YouTube channel. We'll be posting the live stream links there. You'll see our full slate of Friday night live streams and some Saturday events too, because we have some exciting events in astronomy, including Astrofest and our solar eclipse in October, which we've got a real special virtual and in-person event planned for the solar eclipse. So stay tuned for announcements there. Oh yeah, look, there's people out getting pretty close to it now. Shaitan asks, what about the Orion meteor shower in October? We are planning to do a stream and also have an in-person event for the Orion and meteor showers too. So we'll make sure to get that going as well. That'll be part of our fall slate. You'll see that rolled out with everything else. How neat to be the first people to be standing right up close to this craft that has been out in space for 7 years. And launching in 2016. Actually, I have all the mission dates here, the milestone dates. So it launched on September 8th, 2016. It reached Bennu on December 31st, 2018. And it landed and picked up that sample on October 20th, 2020. And now today, it's next milestone is today's landing on September 24th of this year. And now, as you see above me, OSIRIS-REx is traveling out to asteroid Apophis. Now, this will not collect a sample return. There's no capsule to send that back aboard the craft anymore, but it will be studying that asteroid next. It's studying near-Earth asteroids that are near-Earth asteroids, like near-Earth objects, are ones that are potentially hazardous to Earth, that could eventually impact our planet at some point in the future. So that's part of this mission. It's partially for our security on our planet, but also to study ancient solar objects in the solar system. Oh, I may have missed it, Joe. Did they take a selfie out there? I would hope so. I mean, may as well. You gotta um, live in the moment there. Oh, we got. It looks like they're making contact with it now. Little hand temperature test, maybe? I don't know. Probably not. Yeah, it is surprisingly small. Like I said, you can kind of wrap your arms around in a bowl shape, and that's about the size of the capsule, more or less. So let's bump up the volume here too. And what my dad says. You're right. That is what it, it is like the Thor movie. That is kind of the visual we got going on here. This mysterious object that landed from space. What the grad students are there for? Oh no.
Assessment is successful. Victoria has confirmed that with her gas readings and thermal measurements of the SRC. They'll then go back over, Stu and Victoria, for a team huddle to prepare the rest of the team to begin the recovery operations and actually get this SRC into our clean room here at Dugway and continue the operations. You can see the Lockheed Martin team in the bottom left of your screen, just overjoyed with this moment. This is years of careful planning and preparation leading to this final phase of getting that sample back here to our clean rooms. I'm sure they've been holding their breath all morning, so they're getting closer to finally being able to take another breath and relax as we actually will begin our recovery operations, a key part of today's events. And you might see Victoria approach over and over once again to that SRC to continue to take gas readings. At this point, she appears to be covering up the back shell of that SRC, placing a Teflon cover over. This is where the parachute actually deployed at the top of the SRC capsule, the sample return capsule rather. She'll also be checking for any possible live voltage. And we'll wrap Kapton tape around the two cut cable ends protruding from the back of the SRC where that parachute deployed. You can see her with that covering as we speak, placing it on the back shell. She has successfully placed that shielding on the back, that Teflon cover. Stu walking around behind, checking the rest of the scene, walking back with the parachute that he now has safely stowed away. And you'll see Victoria opening up a couple gas valves on the SRC, taking those gas readings. Continue to do this throughout the whole process. She's also placing covers on those gas vents too to prevent any kind of contamination from atmospheric particles, particulates entering into that SRC. She's photographing the scene as well too. This is to keep careful note of exactly the procedures that she's going through for her team. So the recovery operations will be getting underway shortly now that the team has conducted their initial environmental and safety sweep. Everything appears to be nominal, which is fantastic. We do, in fact, have that SRC on the ground. The rest of the team will be approaching shortly. But for now, back to you, Lauren and Jim.
Wow. Thank you, James.
Oh.
Can you believe it?
OMG. Touchdown for science. What a great day.
For the folks at home, this is a huge deal, and they did it.
For the first time in history, we brought goodies back home from this kind of object in the history of humanity. So
goodies. Yeah.
This is so huge, and we're all breathing a big sigh of relief. Obviously, we're not completely out of the woods here, and we'll be monitoring what's going on and keeping you abreast of everything that's happening. But for now,
wow,
we made it home.
A great job by that Lockheed Martin team safing that craft.
Fantastic work.
What a spacecraft. We have to name her specially.
Yes, absolutely. In that capsule, everything perfect. So while the capsule was making its way to the ground, mission teams...
Recovery operations, all vent covers are in place.
All right. All right, so we're
That's
making
good.
progress.
We're
Very
making
good.
progress.
All right, so while the capsule was making its way to the ground, mission teams in the Colorado control room and the mission ops area here in Utah were, of course, riveted by the live images. These teams have watched and nurtured this mission for more than 7 years of spaceflight, and even longer in terms of construction and design. Gosh,
wow.
Amazing.
11 years since it was selected to fly. What a job, folks.
Just fantastic. A lot's happened in 7 years. All right, so let's get an update from where the action started this morning. Sophia, tell us everything.
Okay, firstly, I want to say we are so grateful that the capsule is on the ground and in good hands now. Now, from here, from Whig Mountain, I am overlooking the vast landing zone, which, again, is larger than the state of Rhode Island.
Wow.
So, during that time,
pretty
listening to
beautiful where
James's
they're at.
commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast ancient seabed. So the mountains that are peppering along the edges over here, they are very muted colors. It's beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be, and that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen, and it's still a great day. So back to you, Lauren.
That was actually pretty neat to get that geologic context for where they're at. It just kind of brings the whole all the science together, right? Of like why we went to this asteroid, coming back to Earth and landing at this landing zone. It interconnects the sciences behind it. Oh, here's the administrator.
You did it. You designed it. You built it. And you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth. And it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things. Things that inspire us, things that unite us.
Recovery operations, we can confirm that the SRC is not breached.
Beyond our reach. And the mission continues with incredible science and analysis going to come. But I want to thank you all for everybody that made this OSIRIS-REx mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic, fantastic news. All right, as anyone who pays just even a little attention to modern spaceflight knows, there has been more activity above the planet in recent years than ever before in human history. There are probes like OSIRIS-REx moving around the solar system, observatories looking out into deep space, and satellites closely examining the health and future of our own planet. There are also human explorers, and we are so fortunate to have 2 of them with us here today. Joining us now are NASA's astronauts Butch Wilmore and Sunny Williams, scheduled to launch on Boeing's crew flight test aboard Starliner to the International Space Station. Butch and Sunny, thank you for joining us.
We are honored to be here.
Super exciting day. Congratulations.
Absolutely historic. How are you feeling?
pretty amazing.
It was like, wow, this is what, dreams and imagination is fueled with. This is just amazing. So, it can go from the movies, but this is reality, and we're doing things that people couldn't even believe could happen. It's amazing. Yeah.
And also, I mean, we've both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal, but pretty close to exciting and intense, and that parachute opened, it was thrilling. Absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this, of course, this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery operations.
That's the place that our flight
The recovery team is performing their safety.
This is a beautiful place. It's a beautiful day this morning. No wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride just like this capsule too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So you guys will be coming back, and maybe someday with samples yourself, brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, headed back to Moon, and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier. So much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise woman.
I'm super glad the spacecraft did it, and we'll set the pace and show us how to do it. But I think maybe you'll practice a little bit more before we go, because it's a dangerous environment learning about it.
So much Sunny and Butch, thank you so much for joining us today. Hopefully you'll stick around for more of the show.
All right, congratulations,
thank you guys.
everybody out there.
Really appreciate it. Thanks, guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS-REx asteroid sample return mission.
It's nice to have some context and perspectives from the astronauts. It's always fascinating to bring them in and see what they think of these missions, robotic and otherwise. Let's see. Yeah, Catherine, it would be fantastic to see what science they can glean from these samples that they've collected. Oh, a phone with built-in FLIR. That's pretty cool. Pretty handy too. We have an attachment for a smartphone at Kopernik that we've used, a FLIR attachment. But to have it just built in and on you at all times is nice, to be sure. All right, let's see what they're chatting about here. Oh, okay. They're showing you the landing zone, which is pretty nice to get these nice landscape shots. Okay, there's the capsule. Getting closer with our video footage here.
And look at this. We're in this place that almost looks like Mars, but on Earth, as we're recovering a capsule with the pieces of our universe that will tell us about the early time of our solar system that we can't get anywhere else. And there's the crew out there approaching that beautiful capsule that did the joyful ride from that top of the atmosphere down. 13 minutes of roller coaster riding, and they're getting it safe and ready to start bagging her to come over to the clean room here.
Wow. And explain, why do we do a landing, as opposed to an ocean landing?
So many of our crews land in the ocean, as you know from Apollo. But for this one, we need to bring it back to a place where we can contain the contamination. By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
Absolutely.
It really does.
Well,
perfectly balanced. I love it.
NASA has visited Dugway, and it certainly won't be the last. Take a look.
When bringing a sample of the cosmos back to Earth, it's important to find a good landing zone that won't compromise the sample. That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it ideal for the task. But OSIRIS-REx is neither the first nor the last mission to land here. In 2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006,
That looked quite chaotic watching that descent.
With a mission called Stardust, which gathered samples of interstellar dust.
Was it supposed to land that way?
Fuel our understanding of the universe, and wouldn't have been possible without a safe landing zone, just like OSIRIS-REx. After today, NASA and Dugway are looking towards the future, to the Mars Sample Return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground.
Oh, great. Okay, so it's going to end up right here when the Mars sample returns come back.
Have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery operations. Nominal SRC recovery operations have begun.
An update. Okay. All right, nominal SRC recovery operations have begun. Okay.
Pretty darn good.
All right. Okay, so today could not have gone any better. How did it, I mean, in large part due to our amazing partners here with
Yeah, that craft really was tumbling.
From your end?
Oh, it looked amazing. So when you talk about partnerships, this isn't just a Dugway Proving Ground effort. Though you're sitting here on Dugway Proving Ground, the capsule actually landed on the Air Force's Utah Test and Training Range, and so it's going to be brought here to Dugway before it goes to the clean room. So this is a larger effort than just the Army's Dugway Proving Ground and NASA.
And it looks like it might have landed right.
So I got a note just before this from the commander of the Utah Test and Training Range that it did land on Uter, and so there was a little bit of rivalry there. We were hoping, but it looks like it was on Uter.
Right on the boundary, though. Yeah. So close.
So we have a big collaboration at NASA with members from the Army and Navy, from the military services that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little bit about the training and other fantastic things you do prepares these people to be crew for flight into space?
Yeah, so if you look at it, the Army is the greatest leadership lab in the world, the types of problems that we have to solve on a day-to-day basis. And we have some of the best workforce that is available. So here at Dugway Proving Ground, we do chemical and biological defense testing. We're part of the Army's Test and Evaluation Command. And so anytime a piece of equipment is going to go into a service member's hands, it's tested by one of our amazing members of our workforce. But we also do training here. And so it gives a chance for folks to come and do things in a realistic environment. And that really allows them to hone those problem-solving skills.
So that's why the crews are so good who come from the Army and the Navy and the Air Force.
Yeah, we'd like to point out it was an Army astronaut this week who went over who set the record.
Oh, well, there you go. There you go. Well, we couldn't let you go without wishing you a very happy birthday today. Happy birthday today.
Thank
is
you.
your birthday, and
Wow,
you got a
that's
piece
fun.
of the solar
That's
system.
quite a birthday present, isn't
I
it?
don't think I could have gotten a better present from NASA.
Yeah.
And this is the rarest stuff we've ever had on Earth.
It is, and I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here, and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of the solar system. I think we've set the bar pretty high, and so my kids think I'm cool today. I don't know what we're going to do to top this.
Well, we think you're pretty cool,
yes.
too.
Yes, sir.
And thank you so much for joining us. We've really loved having you.
Thank you so much.
We have a saying at NASA that the only way to reach the stars is if we all go together. The OSIRIS-REx team represents pros at the top of their game, but future explorers are just now finding inspiration in today's events. Here at the Dugway Proving Ground, students attending public school can literally say that a sample of an asteroid landed in their backyard. We visited the school to hear their thoughts about the mission and how their teachers hope it might influence their dreams of future exploration.
My name is Deborah Rockmore, and I am the librarian here at Dugway Elementary through High School. I love that Dugway is part of this. We have a very strong feeling about Dugway. It's a wonderful base to have it be a prominent area where this is coming down is really amazing to us.
Well, I'm just glad that this little town is getting noticed.
It's
Aw.
a big rock that has kind of like holes in it because they've been flying through the sky with fire. Because it goes really fast.
Honestly, I find it really cool because you don't really expect this stuff to happen, in your backyard. But I really wish I could see it, but I don't know. I'm going to try my hardest.
I became interested in the mission because I have the NASA app and I get daily updates on photos, and one day I saw a photo that had that Dugway, Utah titled on it, and I was like, I live there. You hear about exciting things all over the world, and it's cool to hear about, but you kind of never think that you'll be, I guess, directly or indirectly involved with it. But to know that it's just happening here within eyesight is pretty cool. Let's go OSIRIS-REx!
Go OSIRIS-REx!
Let's go OSIRIS-REx!
Let's go OSIRIS-REx!
Let's go OSIRIS-REx!
That was an awesome video. I didn't know about that connection. But yeah, to hear those students so passionate about this event happening right in their backyard is that's amazing. That's going to be some heavy inspiration for them moving into the future. How cool.
You'll be inspired by the rocks and the things in space, like these special samples we've brought back, which are unique being from Bennu, but not unique in the kinds of materials we have here on Earth, thanks to other asteroid returns. These are the biggest we've ever done, and so we're excited. But I think curiosity is in all of us, and so that's really what it's all about. And these kids are ready to pick up on this energy.
Yeah, we need that future generation. All right, let's get an update from James. James, go ahead.
Yeah, Lauren, so the mission operations team has confirmed that we are able to begin those recovery operations. You've been seeing on your screen in the bottom corner for the past couple minutes, team members beginning to head out and put flags of areas of interest where we'll want to sample for our sample curation team. And also just a note on our parachute deployment, the parachute was set to deploy based on capsule deceleration, and we actually reached that threshold earlier than predicted, and the parachute deployed appropriately. So everything was right there, working perfectly fine. We got that SRC, as you can see, successfully on the ground. It is perfectly resting on the desert terrain, and you see 3 of our team members around that capsule beginning to place flags to begin to collect samples. The team members here you see on screen are Scott Sanford, Dante Loretto, the principal investigator at the right of your screen there, and Francis McCubbin. These are key curation team members who will help us actually get a lot of these samples of the region there, environmental samples, collected and ready to be passed along to our team at the Johnson Space Center for curation efforts there. This is, again, a very key part of the mission. We want to make sure that there is no contamination of that sample return capsule from any possible atmospheric or environmental conditions out at that landing zone, that landing site. And so we're going to continue these operations and actually begin to scoop up some of the samples. And this will work like a well-oiled machine you'll see in a few moments. Dante, who was just on your screen a few moments ago, is wearing an armband, much like a football quarterback, if you will. He'll actually be kind of reading off the play calls as they go out and go step by step to actually scoop into the terrain about an inch down into the surface of the desert, scooping out a little bit of the rock and dust that's there, placing it into a bag, photographing the whole process along the way, making note of exactly where they collected that sample from. All this information will then be passed along to our sample curation team at the Johnson Space Center as they begin to actually open up that sample canister and see exactly what we got within. This has been a long journey. It's been an incredible morning to witness this live. Just such a stunning feat of engineering to get that capsule back here to Earth with samples of the asteroid Bennu. This is why we do science, right? To get these kinds of samples, every piece of dust and grain inside that sample return capsule is a PhD thesis waiting to be written. It's a new discovery.
Yeah, it's a good way to put it.
About the origins of the solar system and our place in it. And the vast majority of that sample, more than 70% of that sample, is actually going to be stowed away for future analysis. We did the same exact thing with the Apollo missions when we brought back rocks from the moon. A large quantity of those rocks and dust from the moon our astronauts brought back were stowed away for future generations with the expectation that our technology will continue to improve and improve and improve, and then we'd be able to ask questions that we couldn't even begin to fathom. And now the same thing we'll be doing with the OSIRIS-REx samples that we brought back from the asteroid Bennu. A lot of these will be opened up 50 years from now with scientists who are yet to be born, asking questions we can't even begin to imagine. So our team is just huddling off screen now, and our recovery operations will begin. You'll see a number of team members come out here. They'll be carrying with them a carrying fixture. It's a large metal fixture that has been perfectly designed to have our SRC resting within. They'll be bringing out a lot of thermal blanketing that will be used to protect our SRC during its flight back to the clean room here. Again, we want to make sure that that SRC is safe from any kind of possible contamination from the atmosphere. So they're going to do an excellent job of actually wrapping this SRC up and getting it prepared to transport to our portable clean room. That actual operation of getting that SRC bagged and stowed and ready to go on our long line operations for the helicopter will be a rather quick operation. As you see some team members from Lockheed Martin, their role is largely finished for today. They were operating a lot of the flight dynamics of that SRC, getting it to the ground, and now they can really just take a step back and relax, catch their breath after all the chaos of the morning. Very exciting moment for all of them, I'm sure, to actually see their creation sitting on the surface of the Utah Test and Training Range. Just massive, massive sigh of relief. So as I mentioned, that actual recovery of the SRC will be a relatively quick process, but a number of our team members, including Dante Loretta, our principal investigator, might remain out on the site where you see that SRC on your screen now. They're going to continue to collect samples. You can see a number of flags placed around. There's some pink flags placed there. There are 4 placed in front of the SRC where the team believes the SRC is potentially dragged along the surface as it came to a rest on the Utah Test and Training Range desert surface. On the back side of that SRC are 4 additional pink flags, and those are our regions for control sampling. We'll actually go and sample all of these regions and compare back to areas we believe the SRC did not contact. You can see additionally, it's a little bit hard to make out with the bright color of the desert, but there are a couple white flags present at the SRC. And these are areas of operation for the team to actually be able to walk up to the SRC with the carrying fixture, place it next to the SRC, and actually begin to bag and stow our sample return capsule for transport to the Dugway clean room. So it's been already just an incredible morning. We're now about an hour past landing of the OSIRIS-REx sample return capsule. Just a few years ago, our spacecraft, our intrepid robotic explorer, was 200 million miles away from us on the other side of the solar system. It successfully captured a sample of the asteroid Bennu, stowed it away, and transported it on the long 1.2 billion mile journey to us here on Earth. We experienced an incredible entry, descent, and landing as this team that you see on screen here, the Lockheed Martin team, a couple hours before our broadcast started, gave the green light, the go command to actually release the sample return capsule containing pieces of the asteroid Bennu. It then floated on its own through the vacuum of space for about 4 hours before coming in contact with the atmosphere over the San Francisco, California Bay Area, traveling at just over 27,000 miles per hour and heating up to over 5,000 degrees Fahrenheit as it encountered the incredible drag forces our Earth's atmosphere presents. We then slowed down under our drogue parachute initially, which kept us stable during our descent down to the Utah Test and Training Range. And then ultimately, at about 20,000 feet off the deck, we gave the command to deploy our main parachute, that orange creamsicle colored parachute that has now actually already been stowed away by our team members here at the Utah Test and Training Range. It's been a really wild journey. Very excited to have our SRC on the ground.
Hello, Pickle. So what's happening is they actually gave a decent summary there, but you may have tuned in a little bit after it, that the OSIRIS-REx mission hit a new milestone today where it delivered the sample return capsule, which had material from asteroid Bennu that had picked up a few years ago now, back in 2020. And it returned that to Earth today. This capsule that you're seeing on screen right now is the capsule that the sample is stored in. And up until today, it was traveling through space to return home. This has been a pretty successful mission. I would say. And it's actually not over yet because OSIRIS-REx above me there is still flying in space right now. I can actually adjust the view so you can see. Actually, yeah, it got quite a ways away from Earth already. It's pretty close um, when this landed because it dropped off the capsule, and now it's flying out to asteroid Apophis. No, it won't collect a sample at an asteroid Apophis, but it will study that asteroid up close. So this spacecraft was designed to study near-Earth asteroids like Bennu and Apophis. So they are just getting started about collecting this capsule, and they're going to bring it to a portable clean room next so that they can recover the samples and eventually get them shipped out to their site of testing and study.
And there's all kinds of systems in place by our team to allow us to understand the level of contamination. So what we study in science is the pristine asteroid.
That was a great question.
Excellent question.
Excellent question.
Recovery operations. SRC is bagged and secured in the handling fixture.
All right.
All right.
We just heard that the SRC has been bagged, and we are well on our way to getting that to our clean room here at Dugway. Wow, fantastic news. Missions like OSIRIS-REx transform scientific pursuits into engineering challenges. Smart, curious people with pursue answers with creative verve and perseverance. This year, Hollywood also had a story about a crowd of people situated around the touchdown point of an asteroid. And, well, we couldn't help ourselves. We asked the cast of Asteroid City to say a few words.
Oh, yeah, this is I thought an okay movie. I enjoyed it. Oh.
All right. Well, it looks like we are having some technical difficulties, but that's okay. We'll definitely get you.
I was interested to see what that was about.
Scarlett Johansson, I mean, A-lister. Yes. Can you imagine? All right. So let's get an update from our field correspondent, Sophia. Sophia, do you have an update for us?
Okay, Lauren, turns out the landing site really is just over my shoulder. It is just so hard to see through the alkaline particulate out here on the landing zone. But you know what? This is all in great hands, and we are just very thrilled that the capsule is doing well today. So I'm able to see one of the helicopters just circling over there. But for those of you who have just tuned in, I am on Wig Mountain, which is overlooking the ellipse, which is the vast landing zone. And earlier today, the helicopters, which were shuttling our teams of experts and our scientists, departed from here via helicopter once they found out exactly where the capsule landed. And now they're off on their recovery process and are doing what they do, which has been a carefully rehearsed process. So, Lauren, I'm going to send it back to you.
Great. Thank you so much, Sophia. All right. Well, let's get back to that awesome video of Asteroid City. You don't want to miss this. Take a look.
Hi, I'm Jason Schwartzman.
I'm Jake Ryan.
And I'm Scarlett Johansson.
Where are you?
Asteroid City, Farm Route 6, Mile 75.
Hey everyone, I'm Jeffrey Wright. Junior stargazers and space cadets. Each year we celebrate Asteroid Day.
Hey everyone, I'm Maya Hawke.
And I'm Rupert Friend.
And we star in Wes Anderson's new movie, Asteroid City.
In the movie, families from across the country gather in a fictional American desert town for a junior stargazer convention.
I heard there's a real-life reason people will be gathering in the Utah desert this September.
The world will never be the same.
What is happening there on September 24th?
September 24th is going to be a historic day. This is NASA's first asteroid sample return mission and the biggest sample return beyond the moon. Shortly before 9 a.m. local time, the OSIRIS-REx spacecraft carrying precious samples of asteroid Bennu will release the capsule into the atmosphere to lower the samples down to the Utah desert, where scientists are anxiously awaiting the return of these materials.
Wow, that sounds like the plot of a science fiction film.
It's incredible that a spacecraft can go to an asteroid,
grab some pieces of it, and then bring them to Earth.
So what will NASA look for within the asteroid sample?
These pristine asteroid materials will be studied by scientists from around the world. We're going to be looking at the minerals. We're going to be dissecting the rocks, looking at it mineral grain by mineral grain to learn more about how the solar system formed and evolved. We're also going to be looking for water to try to understand how our Earth's oceans came to be. And then finally, we're going to be looking at organic compounds, including some of the basic chemical building blocks of life, to try to understand whether asteroids like Bennu could have delivered the building blocks to Earth, leading to the origin of life on Earth and potentially elsewhere. With the data we obtained from these materials, we're going to be rewriting the textbooks on solar system formation.
Fascinating stuff. But don't fragments of asteroids land on Earth all the time? Why can't we study those pieces instead of a mission to bring this sample to the Earth?
Yeah, that's a great question. I mean, in fact, the Earth is constantly being bombarded by fragments of asteroids in the form of meteorites. But one of the big problems with studying meteorites is you don't always know where they came from, and it also can be contaminated.
Fair enough. It makes sense that we'd want to study something more pristine.
So how will NASA protect the sample once it's on Earth? And can I have some?
Oh, I wish we could have some of these samples. I wish I could bring one home with me to put on my dresser at home. But the reality is these samples will only be for educational purposes in scientific research. The samples will be transported to the NASA's Johnson Space Center, where they built
Okay, that's where they're going
curation
first.
facility just for keeping these samples safe and pristine.
This is also incredible. I'm so glad that NASA has teams of people that are searching for the answers to some of the biggest questions, like where did life and water come from? Where did our solar system come from?
I can't wait to see what we learn from the asteroid sample OSIRIS-REx is bringing to Earth. Thank you for all that you do.
This is also incredible.
Thank you so much for all you do.
Well, you just said that name. You just said OSIRIS-REx. That was the thing.
That was kick-ass.
How did you do that? I was like, what is this phrase?
I was like,
OSIRIS-REx.
OSIRIS-REx.
Yeah, Osiris. OSIRIS-REx.
Wow, talk about that mega wattage star power.
That was a pretty neat collaboration. Granted, yeah, scripted, but that movie was quite a bit of fun. I enjoyed it. I think it was certainly a mixed reaction to it, but I don't know. I think I had a good laugh throughout most of that film. And in case anyone's wondering too, they were kind of trying to figure out OSIRIS-REx. What could that mean? Making sure they're pronouncing it right and everything. I don't know if I will ever, memorize this or remember it by heart or anything, but I figured I'd share with you what OSIRIS-REx means. It is an acronym. So it is Origins, Spectral, Interpretation, Resource, Identification, Security, Regolith, Explorer. It doesn't roll off the tongue, really. It's a little bit difficult to remember that one, but I think it was probably a case of they probably were shooting for the name. They probably had a couple of different options, but they liked Osiris and it built it out to make it make sense. But yeah, the Origin, Spectral, Interpretation, Resource, Identification, Security, Regolith, Explorer. So that's OSIRIS-REx. It looks like, if you look in the little thumbnail there in the lower left, they have it all packaged up and ready to go to the clean room. And that's what's going to come next. This story will continue to evolve. We saw it's going to go down to NASA Johnson in Texas. That will be where they start curating the samples. And they'll find their way probably to some other institutions as well for study. But we've got some exciting science that will develop over the next couple of years. And as I mentioned before, we will be having a subject matter expert come in to talk about OSIRIS-REx on October 27th. Now, again, it'll still be early days for this, so there's not going to be a ton of new developments, but I think it will be an exciting discussion. And prepare your questions ahead of time. We'll be just like normal on our Friday night live streams. We'll read those out in the chat to our presenter, so you can get your answers live. We have a whole slate of fall programs coming up to look forward to. We'll be starting to promote those in the next few days, so please look forward to those. Subscribe to our YouTube channel if you're not already, and I'll be tuning into this NASA live stream throughout the day to see where they're at. And getting updates on where the samples end up. And of course, you can also look for updates at nasa.gov for this. Check out Eyes on the Solar System too if you haven't already. I really recommend that tool for staying up to date with NASA missions and seeing where they're at live. You can really play around with exploring the solar system, and it's all through the web browser. So yeah, I think that was a good summary of today's event. Congratulations to all those that worked on this project. Oh my gosh, they're hugging Bennu. So congratulations to all the scientists and engineers and trackers today that actually were watching the spacecraft return to Earth. We're going to see some brilliant science develop from this. So thanks for tuning in to our Kopernik Reactions live stream, and we will see you on Friday for our next Friday night live stream. That will cover actually a computer science topic. It's actually the title of it is Was the Internet a Mistake? So getting a little bit in depth with the more negative aspects of the internet and how we can work against those. And thank you, Joe. Thanks for tuning in as always. And yeah, like I said, we'll be streaming out again on Friday for our Friday night live stream. All right, thank you all, and look up and dream big.